All right. This lesson is on graphs of proportional relationships. One thing I need you guys to start getting used to, when you hear the word proportion and graph, what kind of equation are we going to be using? It should trigger something. A linear equation, absolutely. Because when you hear proportional relationship, it means it's going to go up at a rate, which is what the letter in front of x is going to be. What was our original equation when we talked about a linear equation?
Y equals mx plus 3.
Plus b. It's not necessarily 3 every time. Y equals mx plus b, but you're correct in your formatting. Here you see that they have used the formula y equals kx. It's the same formula. The difference is they're just kind of trying to make you think about the k, which is also m, as a rate of change, as a proportion. When you hear proportion, you can also think fraction. Okay, because a proportion is comparing one thing to another as a fraction. Long story short, all of this translates to writing a linear line on a graph. Okay, so this is where we've started learning what slope-intercept form is. We've started learning how to dissect our linear equation to be able to graph it. So let's look at our visual model here. For the positive, you already said it, positive or negative line? Positive, because it's going up from left to right. For the positive values of x and y, meaning we're not going to graph anywhere else in our coordinate plane, because it's probably a real life problem and you can't have negative granola bars. As x increases by a certain number, y increases by a certain number. We learned that, right?
Yeah.
In this case, what does x increase by?
1.1.
1. And what does y increase by? 2. Rise over run. Rise over run. So as x increases by 1, the y increases by 2, which makes sense. If I go from 0 to 2, you see the next point. 2 to 4, you see the next point.
Wait, well, that's actually smart. I thought you said x was 1.
I did. It's right here. X was 1.
Yeah, but then x on the thingy is 2.
No, I didn't say, okay, I'm saying the rise is 1 and the x is 2. So I went up 1 over 2. Up 1 over 2. No problem. Thank you for asking that question. Okay. And then what is 0, 0 also called?
Origin.
We're going to get this vocab. You guys are doing great. All right. So let's look at our example 1. Put this in your journal. Example 1. So they're giving you an equation. Write that down. Y equals 2x. And they've even solved the points that you could solve on here. You do not have to write this in your journal unless you want to. Feel free.
Okay.
So they made an x and y table. They gave you the origin. And then they said 1, 2, 3. And they plugged in 1 where that x is. What is 2 times 1?
2.
So you see they got their y value 2. Now we plug 2 here.
4.
2 times 2 is 4.
2 times 3 is 6.
Plug in the 3. 2 times 3 is 6. So now we have 4 points on our graph, correct?
Oh, yeah.
Could I also graph it just by looking at this equation?
Yes.
Yes. When I look at this equation, y equals mx plus b, what is my y-intercept?
0.
0. So my first point can go on the 0. Graph in your journals. You do have to do that. Graph in your journals.
Okay.
So draw a little graph like this. So my first point is at 0, 0. I'll give you just a second to draw your little graph.
Just the numbers too.
Yes. Just zoom in so you can see it.
Wait.
I like the little Kit Kat. All right, everybody just about have a graph? I don't want to go too fast. Did you just now notice?
I was racing something. I didn't race.
Thank you for sharing. Good class. Good classmate.
Yeah.
All right. So now we have our origin Point at 0, 0. What is my slope?
2, 1.
2 over 1. Everybody agree with her?
Yeah.
Yes, 2, 1, because it's a big number 2 in front of the x, which is your slope. If it's a whole number, you put it over an imaginary 1 to make your rise over run. So from the origin, I'm going to go up 2 over 1. You notice that there's a place where it crosses. So you can put a dot there. Then you can connect your dots and draw your line. But I can go up 2 more over 1 and another dot would appear. Another up 2 over 1 and another dot. If you look at here, all of these dots are these points.
Oh.
How do we feel? Confused? Not confused? Ask questions, clarify. If you're thinking it, somebody else is. So please ask questions. That's it. That's all you would do for your answer. Done. You graphed it. Okay, almost all of this type of work, I want to see the linear equation, I want to see the graph, or sometimes I want to see the coordinates. Somebody give one coordinate on here. Leona.
1 and 2.
Comma 2.
1, 2.
1, comma 2. Melly, give me another one.
2, 4.
2, comma 4. And Evo, give me another one.
3, 6.
Very good. So they picked the one straight off of here. Perfect. Could you pick one of these ugly half ones?
Yes.
Yeah, you could. They're hard to say, but you could.
0.5.
That'd be,
0.5.
yeah, half
And then,
and 1. Julie, question.
So I understand the table, but I don't understand the graph.
Okay. The graph, creating the graph from the line is the,
Yeah, from the table.
from the table, you look here, we have 0, 0. So then I made another point. So this is my x value. So I go over x to 1. And this is my y value, so I go up 2 and I put a dot. Does that help? So then I can do it again. 2, 4, so I go over 2, up 4, put a dot.
I like that one.
Cool?
Yeah.
Perfect question. Any other questions? These are good questions. All right, good? Okay, let's look at number 2. Okay, so we have another real life word problem. The table shows the amount in gallons of gasoline that a car uses to travel X number of miles. So the miles goes on the bottom where the X is, because they specifically told you. So the Y is the number of gallons. Okay, so if I drive so many miles, I'm going to use up so many gallons of gas. At least he's responding and interactive. All right, so if I pick some miles here, we pick 20, 40, 60. That's going to give me a good idea of how many gallons I'm using, correct? It's just getting out of hand now. Question.
I'm dead.
Well, I'm not done talking because y'all are just going, which is entertaining. All right. So they gave you this table so that you don't have your slope intercept form, do you? You just have the table. So we can use this table to graph it. So you can see it's by 20, 40, 60. So they did their gallons in 10, 20, 30, 40, 50, 60. And then they did their number of gallons here. So miles and gallons. So I'm going to go over how many? And up how many? So over 20 gallons, up 1 mile. Over 20 miles, up 1 gallon. So every 20 miles, I'm using how much gas? 1 gallon. So now if I go another 20 miles, I hit 40, right? Which is how many gallons? 2. Go another 20 miles to hit 60, and I use 3 gallons of gas. They're going to ask you, can you tell me whether X and Y are proportional?
Yes.
Yes. Proportional means they change at the same rate every time. AKA, I'm a straight line. However steep or not steep that is it a straight line? Yes, then it's proportional. Could I make my slope-intercept form line here? Yes, I need to know the B. Can anybody tell me what the B is on this graph? Y equals mx plus B? 0. Do we agree with him?
Yes.
Yeah, because that's where it crosses the Y line. 0. What is my slope? Rise over run. I went up how many?
1.
Over how many?
20.
So my slope is
1 over 20.
1 over 20. So you could say my linear equation, write this in your example, y equals 1 over 20x. You could add plus 0 if it helps your brain. Not required.
Plus X?
0. Like if you want the plus b at the end.
Yeah, plus 0.
So it would be plus 0 because b is 0. But you don't have to write that. You can just say y equals 1 over 20x.
Is B always equals 0?
No, b is wherever it crosses the y line.
It could be 1, 2, 3, 4.
Right now on these easy equations, they're making it 0. Later on, it'll start at a number. Question.
What is proportional mean?
Proportional means it goes up at a constant rate that's the same the whole way through. AKA, look up here. We have a straight line.
Thank you.
Good question. Any other questions? Feel good?
Yeah.
All right, turn it over. We're going to do the back side. Now, all you're going to see here is it just gets a little more complicated with our equations. Okay? So, key concept. Y equals 3 minus 3/4 x. Is that a linear equation?
Yeah.
Yeah.
It is. It's not written in the proper form. It's backwards, but it is a linear equation because if I were to rearrange this into my slope-intercept form, all I would do is trade these sides. So I would say negative 3/4 x plus 3. You got to keep the sign with the original part.
Yeah.
The only way you change the sign is if you go across the equal sign. But we just need to switch these two. So put it in slope-intercept form. I'd say y equals, write this down, negative 3/4 x plus 3.
Y equals what?
Negative 3/4 x, because the 3/4 is negative,
Plus 3.
and then plus 3. That's my b at the end of it.
I understand.
Is this a positive or negative slope?
Negative.
Negative, because from left to right, it's going down. What's my y-intercept?
3.
3. What's my slope?
4. I'm at
3 over
3
4.
over 4.
Negative.
Negative.
Over here, the negative. So starting at my y-intercept, I go up or down.
Down.
How many?
4. Wait. 3.
3. So 1, 2, 3, and over 4. You notice they gave you an extra term here, x-intercept. So that means it crosses the x line at 4. If you're ever trying to solve an equation and you know the line crosses both the x and the y value, you can easily solve to graph it because if I plug in where the y is, a 0, solving it is going to give me my x-intercept. If I want to know the y-intercept, I plug in 0 where the x is, and that will tell me my y-intercept. So did you hear me on that?
You write that
You can solve for intercepts by plugging in 0 for the opposite letter that you want. So if I'm trying to find the x-intercept, I put a 0 where the y is. If I'm trying to find the y-intercept, I put a 0 where the x is. We will do that again. So if it's a little milky in your head right now, that's fine. We will do that again. I'm sure it will be in one of your lessons.
Yep.
All right. Any questions on that? So when they're having you do this, they're probably going to ask you, what's the x-intercept and what's the y-intercept? That's probably what they're looking for here. But let's look. So we already talked about all that. Oh, that's what I said. When x equals 0, y equals 3. And then when the y equals 0, x equals 4. All right. So let's look at our two examples here. So they gave you an equation here that we're still dealing with, and they want you to create a table. So again, x is are they input or output values? Input values. So I get to choose them for the most part, unless the question specifically tells you. So always do the origin. It's just a good starter. 1, 2, 3, 4, 5. When you're doing your homework, unless it has a table already pre-made for you, I only require 3 points, not 5. But this one probably has, yeah, this one's asking you to do 4. That's fine. So I'm going to plug this 0 where?
In the X.
Up here. In the x value.
Yeah.
So 0 times negative 3/4 is just
Yeah.
0. So then my y is 3. So now I'm going to take my 1 and plug it in where the x is. What is negative 3/4 times 1? Negative 3/4. 3 minus 3/4 would give you 9/4. You can write it as a mixed because it would just be 2 1/4. Right?
Yep. 2 1/4.
Okay. Please use your calculators on this, guys. Make your fractions simple and easy. You can do it longhand if you want, but you have a calculator. All right, so now I plug in number 2 where the x is. What is 2 times negative 3/4? No, 2, just this part. This is the answer, but what's 2 times negative
1 1/2.
Negative 1 1/2? And so 3 minus 1 1/2
Negative 1/1.
is negative 1 1/2 or 3/2. I mean positive.
Positive 3/2.
Yeah, positive. Because the 3 is still larger than whatever that is. Okay, and now I plug my 3 in.
And that is negative 2 1/4.
And then so 3 minus 2 1/4
It's 3/4.
is 3/4. And then we put in the 4. 4 times negative 3/4. I'm going to guess is 3.
Yes, negative.
So 3 minus 3 is
0.
0. So I'm looking for the intercepts. So have I found the 2 intercepts? Everybody say yes.
Yes.
Because I have 0 for x, so this is my y-intercept. I have 0 for y, so that's my x-intercept. So you don't have to do this if you were just doing it for me on a piece of paper. You found the 2 intercepts, you're done. Okay? If they have the box, you got to do the last one.
Would you go as like when you're graphing, let's say you go to 5 and you start finding the intercept, would you continue until you find the intercept?
I would.
So the intercept is 0?
If that's what we're looking for. Yes. Yeah, if the question is asking what are the x and y intercepts, then yes, you keep doing the table until you have both intercepts. So great question.
So 0 0 for intercept.
Yep.
Okay.
All right, let's look at our last example, and then you can do all 6 problems for homework. I mean, you might even be able to get it done today. All right. A parachutist, that's a fun word,
I like that word.
height in feet is given by h equals 450 minus 15t, where t is time, which means it stands for x or y. Yeah, it's the x value. And h is the height, so h stands for the y value. When does the parachute land? So do you think we're going to do a positive or negative slope? Negative, because it sounds like he's way up in the air and he's going to land, so he's going down. Hopefully slowly. All right. So we're going to plug in different times, which you can see here. They start with 0. Always start with the origin. And then they're doing it by every 5 seconds. So 5, 10, 15, 20, 25, 30, because it's going to take, hopefully, not too short of seconds. If he got to the ground in 5 seconds, I don't think the parachute opened. Would not be good for him. All right. So do we have a slope-intercept form here?
Yes.
Yes. Is it in slope-intercept form? No. It is a linear equation, but it's not in slope-intercept form. So let's rearrange it. I'm going to, since this is a word problem, I'm going to help you with it. All right, so let's change this. We have h equals 450 minus 15t. You're writing this down as an example 2 in your journals. So let's rearrange this into slope-intercept form. How would I rearrange that?
H equals negative 15.
Evo, thank you for raising your hand.
H equals negative 15t plus 450.
Right, you're just switching these, but keep the signs with them. This is a positive 450, that's a negative 15.
Yeah.
So we just say plus 450 at the end. All right, now we have it in slope-intercept form. So we need to know, when does the parachute land? So at what height would the parachute land at? 0. We've made it to the ground. So we're looking for our x-intercept. I'm on the ground. So we're going to make our table here, which you see they've already done. 0, How do we know what height we started at? She's trying to tell me, but I'm going to let, is that a hand? All right, go ahead. Why is it 450? Because it's B, so it's the y-intercept. So it's the very first number we have. So our height starts at 450. So at 0, I haven't gone any time at all. I started at 450 feet. TH. Very good. And then, like I said, we're doing 5. So go ahead and make your table. I know it's up here, but this is good practice. All right, so now I'm going to see how far we go after 5 seconds. How many feet are we falling? Go ahead.
75.
Where are you getting 75 feet?
450.
Because 4 minus.
So let me rephrase my question. How much is our rate of change? Negative 15. Because I said it better, so that was me. Negative 15, because that's our slope. So I just want to know how far we're falling, or how far we're falling per each interval. So after 5 seconds. So we're going to plug it in. Negative 15 times 5 plus 450. So what's negative 15 times 5? You're giving me the answer, I know. Negative 15 times 5 is? Negative 75?
Yeah.
So what's negative 75 plus 450?
375.
375.
Whoops.
375. All right, so we went down 75 feet, yes? Very good. So let me show you something here. If I did negative 75 over, how many seconds did I just fall? 5. What does that simplify to? So you can divide, or negative 15 over 1, technically, right?
Mm-hmm.
Do we all of a sudden see our rate of change?
Yeah.
So this negative 15 is for every 1 second you're falling 15 feet. We are doing the math at 5 seconds, which is why it's 75. See the relationship here? All right. So now we would keep doing this. Do you feel like I need to do it each time?
No.
We got it?
I get the try.
So we see that it's 300 for 10 seconds, which makes sense, down 75 feet. Subtract 75 from that. Down 75 feet would give me 225. Down another 75 feet would give me 150. Then 75, and then at 30 seconds,
0.
we hit the ground. Hopefully gently as you land in your parachute.
Thank you.
So the question says, when does the parachute land?
After 30 seconds.
30 seconds.
We can't just like circle 30 over 0.
Nope, it's a word problem. I want to see you write it out properly with a label. If it's not a word problem, yeah. Any questions on this example? If you got it, go.
Go.
If you don't got it, ask me a question.
Can we not use an extra piece of paper? Because that'll-
Yeah, I don't think you need an extra piece of paper. Good question. Any other questions? Yes.
There's actually a problem.
Is there 8?
Yeah.
Oh, on the back side, there's more than 3. Apologies. A whole lot of 8 problems instead of your normal, 20? I think you can handle it. I believe in you.
Thank you, Dave.
All 8 problems. Yeah, because one side has 1, 2, 5, and the other side has 3. But I make this worth a lot of points by making every single thing you write on here worth 2 points. So like every X and Y, this is 2, 4, 6, 8, 10 points just for that table. These are grade boosters trying to help you for basketball season. I was a coach. I remember. I remember the struggle.
Me and Lily did practice.
Yeah, you did. And Julie. And Julie. Julie only came for like a third of it. She's like, man, this is a lot of work. I'll come sometimes.
I did it for 8 one time.
Yep. I remember you guys coming. And Evo, yep.
Okay.
That was a big scary lady, I know.
I was so scared of all the eighth graders.
Me too.
That class was not a scary class.
I
I mean, my daughter was in it, so it's different.
But I was fourth grade.
And you were fourth grade. You were little bitty. That's true.
I'm ready with 3 men week.
Wait,
Yep.
so do we keep it on the same paper?
No, that's your
Yeah.
journal. So no, you don't have to have a separate piece of paper. You can do everything on the one paper. That paper goes in your journal.
Yeah.
So you can have journal notes.
Oh, okay, so I see what you're saying.
There we go. I just gotta say it a different way. It's fine. I'll get there. Hey, my hiccups are gone.
Yes.
And I'm still recording. Hello, online people. You just got to wander around the classroom.